So let's take a look at this first one. I'm not really going to give any precursors to this. I'm going to write down the example. We're just going to do it. All right. So it's kind of getting away from what we've done before a little bit. There are some things. Let me see. Yeah, there's a couple things that we need to know how to do that we've done before, but we are doing radical equations. What does that mean when they talk about a radical? Give me an example of a radical in math. Nobody? Nobody seen that word before? No, it's not a radical. What is it? Say it. Square root. Square root's a radical, okay? When you get this thing right here, all right, that's a radical. Doesn't have to be just a square root. Could be a cubed root, fourth root, fifth root. Okay, any kind of a root like this is considered to be a radical. All right, that's what this symbol is. Like if I said the square root of 9, some teachers, they don't even say the square root of 9. They just say root 9, all right? Not the root 9, the road out there a little bit ago. But this is a square root, all right? This would be a cubed root. If you had a 4 there, that would be a what? A fourth root, fifth root, sixth root, and so on. That's how you would say that. Everybody with me on that? And you know what a square root does. Like if I had the square root of x equals 3, what would I do to get rid of that square root? What's that? I hear a whisper. I think I heard it. You'd square both sides. Have we done that this year? Can't remember if we've done that this year or not. You did it in Algebra 2 for sure. Did we do it this year earlier? Okay. So you square both sides, and what happens to that square and that square root? They cancel each other out, and so you just say x is equal to 9. Everybody with me on that? All right, so that's how you get rid of a square root. All right, let's, by the way, we're doing equations and what? Inequalities. So we've talked about inequalities. That shouldn't be that much more difficult. I'm actually skipping example 1. Not that it's not important, but I just wanted to get right down to the nitty-gritty. And so I'm going to go to example 2. All right, so here it is. We're going to solve for x. All these are solving for x. And here it is. X equals the square root of x plus 7 and a plus 5. That plus 5 is not inside the root. And there we go. We want to find out, what does x have to be in order for those two sides to equal each other? What do we do first? Just square this and square that? Kind of, but not really. I don't just square this, because I can't just square something in the middle like that. I'd have to do what? Square the whole entire what? Side, correct? You could do that. You could take this, don't write this down. You could take that whole thing and square it. But that can be kind of ugly, all right? So let's think of a little bit of a better way to do that, all right? Let's get rid of that 5 and put it on the other side. And then we'll look at it and see what happens when we square it, okay? Now, what I just wrote right there, you could have done that, but it would be a pain, all right? It would be way too difficult. So I think it would be easier just get rid of this 5. How do I get rid of this plus 5? Subtract a 5. Very good. All right. So this is what we have now. Now I can do what we talked about a few minutes ago. All right. So now I can get rid of that square root. How do I get rid of a square root? Square it. That's right. Do the opposite. Opposite of a square root is to square something. So I square it. Now if I put a squared here, in effect, I am squaring that whole entire right side, aren't I? Okay. So that's good. But what about here? Do I just square the x? Do I just square the 5? Which means I got to put it in parentheses. That's very important. Okay, and then you can square it. So that's the key to this problem right here. The rest is just kind of work. It's just stuff that we've done before. But this is the key to that problem, is if you're going to square one entire side, you got to square the other entire side. You can't just pick and choose what you want to square to get rid of and all that kind of thing, all right? So now, since I moved this 5 over here, now this makes it way better than squaring the square root of x plus 7 plus 5. That would be horrible. It wouldn't be horrible, but it would be bad enough. This is way easier. So we could do this part in our head. We've done this before, can't you? If you can't do it in your head, what should you write down? And I'm going to write it down since this is our first example. Yeah, it's going to be a FOIL problem, isn't it? So I'm going to write down x minus 5 times x minus 5. Okay, what happens here? What happens to that square? They cancel each other out, so I'm left with just x plus 7. See how nice that was? Squaring both sides. So now, doesn't look too bad at all, does it? So what are we going to do with this x minus 5 times x minus 5? FOIL it, right? Just like you said. Or we could have gone to here, because this is a perfect square. Do you remember how to do a perfect square? Right? You square these two, and then you multiply them, and then multiply it by 2, and then that's your middle term. All right? So you could go directly from here to here if you wanted to. But if you can't, if that bothers you, it's fine. Just write them out separate like this, and then just do the FOIL. Make sense? All right, so let's do it. What do we got? X squared. And then we got outside, inside. So outside is negative 5x. You should be able to do this in your head. The outside is negative 5x. The inside is negative 5x. So what does that give you? Negative 10x. Isn't that the same thing as if I took 1x times 5, which is 5x, and then double it? It's 10x, isn't it? Yeah? All right. I want you to start trying to do that in your head. Okay, going from a perfect square to this when you multiply it out. And then you get plus 25. All right, so that's what that is. Equals what? X plus 7. Questions up to this point on what we did? Pretty basic, fairly, kind of. Not Algebra 1 basic, but pre-calc basic. Now what do we do? What do I want to do if I want to get x by itself? Okay, why? I am going to minus a 7. I'm going to do something else too. What? Ooh, don't want to do that. That'll make it worse. Put everything on the left-hand side and then set it equal to what? To 0. That's the key, right? It's a quadratic, isn't it? As soon as I see that x squared and that x, in my head I'm thinking, oh, that's a quadratic. I want to set it equal to 0 because I got tools, don't I, to solve for x with a quadratic. I could maybe factor it. Maybe I could complete the square. I definitely know that I can use the quadratic formula on it. Agreed? All right, so let's do that. So let's move this over. The x squared stays the same. If I subtract an x from both sides, what's that give me? Negative 11x. And then I subtract a 7 from both sides, that gives me 18. And that's equal to 0. This looks like I don't have to go through the quadratic formula. This looks like something that probably could factor. Have you seen the numbers already, or have you thought about it? They have to add up to be negative 11, and they got to multiply to be positive 18. To a 9, that's it, okay? Positive or negative, or one of each. Both negative. They got to both be negative, because they have to multiply to be a positive 18. They have to add up to be a negative 11. So it has to both be negative, okay? That's usually the first thing I do when I'm going to factor something like this, is think of what my signs are going to be, right? Now you know this times this, that's easy. That's x and x. And then what? 2 and 9, 9 and 2 doesn't matter because they're both negative anyway, all right? I put 9 and 2, I'm just going to write what I put. It doesn't make any difference. And now you're ready to get x by itself, aren't you? Let's do the steps. Again, since this is the first example, let's do the step. But from here, you should be able to go directly to the answer. Can you? No? I got silence? All right, let's do this. You're scaring me by your silence. Are you just not saying anything, or you just don't know?
Oh, x equals 9.
Yeah, x equals 9, x equals 2. Right. We've done that a whole bunch, right, in the last couple lessons. All right, we haven't forgotten that already, have we? Okay. So I'll show you the steps. Technically, what would you do? You go x minus 9 is equal to what? 0. And then you would go x minus 2 is equal to 0. Add a 9, x is 9. Add a 2, x is 2. But you thought we were done. We did something to this equation that you got to be very, very careful of. All right? And when you do this, you should always realize what you just did. Right here, what did I do to both sides? I squared both sides. Sometimes weird things happen when you square both sides. So you have to be very careful before you circle your answers. We did all the math right. Everything's good. But there's always a chance. This doesn't always happen, but there's always a chance that one of these numbers do not work. Okay? One of these numbers is invalid, or they use the word extraneous, okay? Meaning it's an answer that's doesn't work. Okay, we'll just say it that way. All right? So what are you going to do? How do I know which one works, which one doesn't? Or maybe they both work, or maybe they both don't work. How do I find out? How do I check? I plug it in. Okay? So let's do that. So let's do checking in a different color. Let's go yellow. All right, so I'm going to write this. So x is 9, x is 2, correct? And I'm going to put it into the original. So we said x is 9, x is 2. Let's put them both in, and let's see if they both work. Sometimes they both work. Sometimes none of them work. And sometimes just one of them works. Okay? Everybody with me on that? So we don't know until we plug it in. So let's do that. So let's do the 9 first. So 9 equals square root of 9 plus 7. You could probably do this in your head, but I'm going to do it, the whole thing. Let's see if the other side is 9. So 9 plus 7 is 16. What's the square root of, so that would be 16, right? So the square root is 4. 4 plus 5 is 9. Does 9 equal 9? Yep, last time I checked it does. So yeah, 9's good. So I can circle 9 and say that that's one of my answers. Let's try x is equal to 2 and see if that works. So let's put a 2 in for this. So 2 equals square root of what? 2 plus 7 plus 5. What's this going to be? 2 plus 7 is 9. Square root of 9 is 3 plus 5. Did I do something wrong? I don't know. So 2, does 2 equal 8? Of course not. So can I circle x equals 2? No, because it doesn't work. It's not equal. I mean, it worked in my math, didn't it? All my math was right. It was good. Okay, but it's an extraneous solution is what they call it. All right, we just say doesn't work. All right, so you can only circle 9. So on a quiz or on a test, if you circle x equals 2, I have to mark the problem wrong because you're telling me something that's not true. Everybody got that? And it seems dumb because you did all the math right. You got the 2 answers. It looked like we were good to go, but it doesn't work. It is not a solution. This is not a solution, so I'm going to not circle it. That's not a solution. This one is. That's your only acceptable answer. We good? All right. How did I know to check for it? Because I did what? I squared both sides. All right, so that's always a time when you're like, oh, I squared both sides. I better check my answer at the end to make sure that both of them work. Again, like I said, sometimes they both work, sometimes neither one of them work, sometimes one does and the other doesn't. All right, and that's that case right here. All right, let's do another one. Everybody ready?
Yes.
That wasn't so bad, was it? Did you write down all the steps? All right. Here's another one. This is example 3. Again, this is straight from the book. Again, we're solving for whatever letter they give you. And here we go. 4 equals, now watch this, the cube root of x plus 2, and then a plus 8 on the outside of that root. There we go. What's obviously the thing we don't like about this we want to get rid of? That cubed, it's not a cubed, it's a what? Cube root. What does a cube root mean? Like what's the cube root of 27? It means what number times itself what? 3 times is 27. So what times itself is 27? It's 3. So the cube root of 27 is 3. Make sense? So that's what cube root means. Because what does square root mean? Right? If I had the square root of 16, what does that mean? It means what times what is equal to what? 16. Right? So 2 times. Cube root 3 times. Fourth root what? 4 times. Got it? Okay. So that's what you're doing here. The first step is almost identical to what we did on the last one. So what do you think we're going to do here? Subtract an 8 from both sides. Good. So subtract an 8, subtract an 8. Let's write everything down. We won't worry about the cube root until the next step. So my negative 4 equals cube root of x plus 2. So the nice thing about doing that is the only thing I have left on that one side is the cube root. So now I can get rid of the cube root. Remember on the last problem, if it was a square root, how do we get rid of a square root? We squared it. How do you get rid of a cube root then? You cube it. That's right. So I'm going to take this and I'm going to cube that. And I come over here, put in parentheses, I'm going to cube that. So what do you think happens with the cubed root and the cubed? They cancel each other out. All right. We'll do the left side in a second. So what do we have left on the right-hand side? Just an x plus 2. So that was nice, wasn't it? But we've got to cube this side. So what is that? It's negative 4 times negative 4 times negative 4. It's going to, first of all, what's the sign going to be? It's going to be negative, isn't it? 4 times 4 is 16. You may or may not be able to do this in your head, but 16 times 4 is, no, 64. Can't be an 8 because 4, you're going 16 times 4. The 4 times the 6 is a 24. So it doesn't end in an 8. So it can't be anything 8. Use your calculator. It's negative 64. 16 times 4. 16 times 3 is 48. Yeah. All right, now the rest is easy, isn't it? What do? Subtract a 2. What's x equal to? Negative 66. Now, before you circle it, what should you do? You should check it, all right? Even though we didn't square both sides, we did what? We cubed both sides. But I want to be certain, okay? I want to make sure that this answer is correct. So what are we going to do? 4 equals the cubed root of x, which is negative 66, plus 2, and then plus 8. All right? Negative 66 plus 2 is negative 64. Cube root. I thought we couldn't take the root of a negative. Well, we can't take the square root, but you can take a cube root, all right? Because what times what is negative 64? Just did it right here, didn't we? It's negative 4. So watch, 4, oh, don't forget that plus 8. So this is what? 4 equals negative 4 plus 8. Negative 4 plus 8 is 4. Yep, 4 equals 4. That works. So guess what I can do with this? I can circle it, and then that's your answer.
So what if that's wrong?
Then you would say no solution. Correct. All right, so you didn't get 2 answers here, did you? You only got 1, but I think it's important to double check to see if that one answer actually works.
So then square roots always get 2 answers?
I was thinking the same thing when I was working this problem. And I just can't say. I don't know. I've not heard that there was any kind of a pattern with it. There could be. I'd rather be safe than sorry and check it, okay? But it's a good question because I was thinking of the same exact thing. All right, you ready for number 3 or 4 or whatever it is? Example 4. This one's a little bit of a doozy, okay, as the old people say, like me. I'm old. So that's a doozy. Anybody ever say that? I think I asked another class that. They looked at me like I was crazy. Like, that's a what? Like, ask your parents. Actually, ask your grandparents. Now, your parents are as old as the people that I've taught before. And so you might want to ask your grandparents. All right, so here we go. We're going to solve. At first, it doesn't look so bad, but then it gets a little bit weird. But the stuff that we've been learning lately comes into play here. Do you remember that first example we did? Let's go all the way right here. Remember that first one, and I said, I really don't want to take that and square it. Remember that? You could have, and it would have worked. But guess what we're going to do on this one? We're going to square something like that, okay? So we got away with it on that first problem, but this one, there's really nothing else we can do. All right? Because if you look at it, what do I want to do? I want to get rid of square roots, don't I? So how would I get rid of that square root right there? I got to square it. I mean, you're probably thinking, well, I could take that 5 and move it over here, or I could take the negative square root of 3 minus x and put it over there, but squaring that would really be tough. So really, the only thing we can do to get rid of that square root is square both sides. Now, be careful. Like I've talked about this before, you got to make sure that you square that whole entire right side. You can't just go 5 squared and then the square root squared. Everybody understand that? You got to square the whole thing, which is different than just squaring the 5 and squaring that square root. You can't just do that. All right. Over here on the left side, worked out nice and pretty because that cancels with that. Now, what do we got to do here? No, you can't do that. What happens when you square a sum or a difference? You do this? What do we call that? Yeah, just put the two things. Just multiply both of these things together. Okay, when you square something, you just multiply it by itself, correct? So let's take that whole thing, 5 minus square root of 3 minus x. Remember we did that earlier, that perfect square, and I was like, you should be able to do that in your head. This one might be a little more difficult to do in your head, so I would definitely write it down. This is where it gets a little bit tricky, but you know how to do this stuff. So be confident. All right, what are we going to do? A little FOIL, right? All right, so let's do it. First, what's the first? 5 times 5, 25. Let's do the outside. What's the outside? 5 times negative. Let's write it down. Okay, so 5 times, it's positive 5 times a negative, which is negative 5, what? Square root of 3 minus x. See, that's the outside terms. What about the inside? It's another negative 5 square root of 3 minus x. Everybody see that? That's the outside. This is the inside. And the last. Well, it's this thing times this thing. They're both negative. So negative times negative is positive. And then we multiply them together. Look, they're the same exact thing, aren't they? So if I multiply those two things together, what am I doing to it? I'm squaring it, right? So what happens when you take a square root of something and you square it? It gets rid of the square root. So what looked like it might be really difficult actually wasn't all that bad. Because this times this is exactly the same thing, so you're squaring it. You're squaring a square root, so that just gets rid of the square root, and so what am I left with? That. Did I do that right? Yes. I was looking at another step, and I'm like, where did I get that? It's because I hadn't got there yet, okay? So let's clean this up a little bit. We can do a couple things, can't we? What can we do? I can add these together, right? I got this 25 and 3 I can add together. I could take this x and put it to the other side if I wanted to, couldn't I? Can we do all that in one step? Yeah. Let's do the x first. Let's take this minus x and put it on the left-hand side. What does that give us here? How do I get rid of this minus x? Plus x. So what do I do over here? Plus x. Okay? So what do I get here? 2x. Right? That cancels. So that was easy. Take it one little step at a time. That's how you climb a mountain, right? Take one step at a time. You can't get there all at once. Let's do this. Let's put the plus 10 here. I don't want to do too much in our head, okay? Just one little step at a time. So what do I get here? I can add the 25 and the 3. What does that give us? 28. So I'm done with that. I'm done with that. All right, and then we got this. Negative 5 square root minus 5 square root gives us? I am. This one? No, I'm keeping it on the right side. You're right, it is a plus and a plus. Okay, I'm just combining like terms. That's all I'm doing. I'm not moving it to the left on this 25 and 3. All right? So what do I do here? Negative 5 minus 5 is negative what? 10 square root of 3 minus x. Everybody see that? Look, it's just like this. It's just like negative 5a minus 5a. What's that? It's negative 10a, correct? Except it's not an a. It's just the square root of 3 minus x. No big deal. So I'm done with that. So I've simplified everything I can. And now, what do you think you want to do? What do we do on the other one? We saw it as a quadratic. I don't see any quadratic yet, but I would like, and we do this almost all the time. What do? We move everything to the left side. Actually, this is your left, okay? Move everything to the left side. So let's do that. So let's move this negative 10 square root of 3 minus x over to the left side. Very simple. It's just a simple process. What do? It's a minus, so what do? We add, all right? So I'm going to add a 10 square root of 3 minus x. And now it's on the left-hand side. I moved it from the right to the left. We got to move one more thing. What's the other thing we got to move? The 28. So I subtract 28, and that's going to go on the end. What would go next, though? The 2x, right? So don't forget about that. And then this would be what? Negative 18. And that's all equal to 0. That's not what I did on my notes. That was dumb. Now I see why I shouldn't have done that. Because I looked at this, I'm like, oh crap, what am I going to do now? And I know exactly. I mean, you could do this, but this next step would be crazy. So sorry about that. I apologize. I should have stuck with my notes. I thought I was going great. But it's only to here. We can still do this, all right? So it's not much different. I'm going to keep this over here, all right? And I know exactly why now. So what do I have on the left-hand side? I got 2x minus 18 equals, so really all I'm doing is taking that 10 square root of 3 minus x and putting it back to the other side. Is that all right? So I didn't backtrack too far. Now, why did I do that? Why do you think I did that? Because I want to get rid of what? The square root. So now it's a lot easier to get rid of that square root now than it was before. All right, the way I wrote it down. So really, I didn't backtrack too much. Took a little side trail, figured out I was going the wrong way, popped right back on the trail again. I've done that a bunch in my hiking days. So what are we going to do? We're going to square this, right? But we can't just square the square root. What are we going to have to do? Square the whole entire side. And square the whole entire side over here. Make sense? So, what do we have? Look, I know there's a lot of steps. We're only about halfway through. But you need to try this on your own. All right? Listen to me. Listen. Stop crying and just listen to me. All right?
Wake up, Shalom.
So watch. What you need to do, you need to watch. Right now, what you need to do is pay attention and watch. Okay, I made a little misstep, but we're back on track. All right? What you need to do is take this problem at home, start it from scratch, and see if you can do all these from scratch. Don't start on the homework. Just do this example and see if you can do it on your own. If you can do this example on your own without any help from me, then you're ready to do the homework. So what do we do here? We square this side. If we square negative, what do we get? Positive. Square 10, we get 100. Now that 100 is being multiplied by this thing right here. If I, come on, don't fade out on me. Come on, stick with it. So if I square a square root, that's going to get rid of it. And so what am I multiplying by? Just a 3 minus x. Everybody look to see what I did. From there to there, that should be easy. What did I do here? I squared this negative, which became a positive. I squared the 10, which became 100. I squared this square root, okay, which goes away, but the 3 minus x doesn't go away. It's being multiplied by this thing right here. So this is being multiplied by that 10 squared, all right? And that's what we get. So write it down, look at it later, and you should be able to figure it out. So now, this works out a lot better than what we had before. So what we're going to do is we're going to FOIL this, all right? So 2x times 2x is 4x squared. That's going to be negative 36x. This is going to be negative 36x, which is going to give you a negative 72, squared, negative 72x plus, I have no idea what 18 times 18 is, but I did write it down. Very good. It's 324 equals. Now, what are we going to do with this thing over here on the right? Yeah, distribute it. So what do we get? 300. No, it's not 300x. It's just 100 times 3 minus 100 times x, which is 100x. This is kind of tedious, I agree. But that's what you got to do. You got to keep at it, keep at it. Just go from one step to the other, one step in front of the other. Now, we need to factor this. If you wanted to, you could come over here and do Pythagorean theorem, quadratic formula. That'd be okay, I guess. And that would work, right? But I'm going to do it another way. If you look at it, I got a 4, 72, and 324. My guess is 4 probably divides evenly into all of that. And it does. So if it does, what do I have left over? X squared minus, and that's oh, you know what I want to do? Let's do this. Hold on. I didn't write that much down. You could do that. That'd be fine. You could go that, but I'm just going to do what I did. Let's put everything on the left-hand side. Before we do any factoring, let's put everything on the left-hand side, set it equal to 0. So let's do that. So I've got a 4x squared, add 100. So what's that give us? 28. All right. Subtract a 300. That makes things a lot easier, doesn't it? What does that give us if I subtract a 300? 24. So now that looks a lot better than what we were going to do earlier. So that's good. Now I'm going to do this. Look, I got a 4, 28, and a 24. What's in common with all of that? A 4, just to make it a little easier for us. And again, I could take this, use the quadratic formula, and get a solution, but I'm going to do it this way. So if you factor out a 4, you get this, you get plus 7x, you get a 6 equals 0. Now, if I divide both sides by 4, what happens to that 4? Just goes away, right? Because 0 divided by 4 is 0. So that's cool. Got rid of that. Now, what can I do with this? Yeah, this is an easy factor. X plus 6, x plus 1. Doesn't get a whole lot easier than factoring that. And now I'm ready for my answer. What's x equal to? Negative 6 and negative 1. Do I circle it yet? Divide both sides by 4. It's being multiplied, so I divide it. So it cancels out. Divide that by 4, cancels out. Divide this by 4, it's a 0. Okay? I'm not going to circle it just yet. What do I have to do? I got to check it. All right, so let's write down, I'll just do it right here. I'm going to write down the original problem. This is actually pretty easy check. Equals 5 minus square root of 3 minus x. All right, so let's check the negative 6. Negative 6 plus 10, 4, square root of 4, 2. Put a negative 6 here. 3 minus a negative 6 is 9, right? The square root of 9 is 3. 5 minus 3 is 2. It works. So I can circle negative 6. Let's try negative 1. So put a negative 1 in for this. So negative 1 plus 10 is 9. Square root of 9 is 3. Put the negative 1 in here. 3 minus negative 1. That's the same as 3 plus 1, which is 4. Square root of 4 is 2. 5 minus 2 is 3. Check it out. They both work. So I can circle both of them. And then that's how we do it. I still didn't do the inequality, but I'll save that for tomorrow. All right, so I will let you... let me see what we're doing tomorrow. Yep. So you're doing 29 to 34. It's not that many. Okay, but omit the ones with inequalities. Say that. They're all inequalities? Every single one of those are? Are you serious? Nah. Where's my book? How did I only do that? Oh, I know why. I know why. Because I split this into two days. I was looking at Wednesday, but remember yesterday we just went over homework. So I was looking at Wednesday. Sorry about this. So 13 to 27. So I did account for that. But I'm only having you do the odds. So forget that because there should not be any inequalities in there. So 13 to 27 odds, section 4.7, call it 4.7a, section 4.7a. All right, 13 to 27, just the odds, all right, and those should be all the equalities. Tomorrow, I'll hit the inequality. There's only one example, all right? So if we had a regular class period, I might have been able to get to it. But you guys are already checked out already anyway, so it's probably good. We'll do the inequality tomorrow. We'll review for a quiz tomorrow, and we'll take the quiz on Friday, section 4.7a.
Whenever students have an ASD after school today, you'll be meeting in the art room to make sure they're by 3:05.